Hey, how you doing this morning? This is Tom, and this is Tom's Radio Room Show. And we're back in our laboratory. I'm going to check out this AC adapter for the Grundig 800. The previous video, I showed you the output of the lab supply that I have up there, which works very well with that radio. On shortwave, there's no noise or hum or RF interference. Works quite well. What I'm going to try to do this morning is show you the output waveform of this little AC to DC adapter. Now, this was made supposedly for this radio. Now, I say supposedly in that it's just a switching regulator that goes from 110 volts AC to 9 volts DC, which is what that radio needs. And I've tried to use it in the past, and it creates this horrendous noise, hum, whatever on the satellite 800 radio. So it's totally useless. The other thing is the satellite 800 radio is notorious to eat batteries. It will operate on batteries. I think it's like 6 D cells, and it goes through those batteries like, I don't know. It's just, I think I left a set of batteries in there, brand new batteries, for about a week. Only used the radio itself for about an hour or two, and within that week they were completely drained. The thing that the radio draws about 400 milliamps when it's turned off. Now, when I say turned off, the big display there is still turned on all the time, showing you the calendar, the clock. So anyway, we're going to take a look at this adapter, which, like I say, doesn't work very well with that radio, and try to figure out what it's doing. Now, here we have my, as some people might say, my dodgy setup here for putting a load on the adapter and hooking the adapter to the oscilloscope. So at any minute, one of these wires could pop off and the whole thing just go up in smoke. So we'll see. So I'm going to concentrate on pointing the camera at the oscilloscope. So I'm going to put the camera in a tripod and see if we've got it in the picture, the scope in the picture. We do. And we'll zoom in a little bit so you can see the scope display a little better. And the scope is in the ground position so that we can zero the waveform here. And it looks like it's just a little bit off. There we go. It's zeroed. Right now I'm on the 5 volts per division scale, and I'm on the, I'll start with, this is the slowest sweep speed, which is 10 milliseconds. So we're going to plug in, everything should be connected unless it came loose during the night. So I'm going to plug this in and see if we can create any sparks. Okay, now I did hear a click from that AC adapter. Now we've got a load on here that provides about 700 milliamps of load, which is similar to what the radio has when it's turned on. Okay, let's go to DC, and we see it doesn't look very high. It looks only about 7 volts maybe. So that load has already dropped it down. Now if I get my meter here, and now we're gonna really get risky. Let me see what my meter's turned on. Well, good way to kill the battery there, Tom. Even the meter on. I don't know when I did that. Okay, anyway, should be able to measure right here. I say should be, you know, be a little careful. There's ground, there's the input. And it says it's 8.8 volts. So I misread the scope there. So it's doing okay as far as voltage. Now, let's crank up a little bit on the sweep, and we'll go to AC. And this is where I think the culprit is. I think this AC adapter, which is a switching regulator, it doesn't have a transformer, is putting out a lot of AC. So let's see. Looks pretty good there, but that's on the 5 volts per division scale. So let's crank that down. And remember, I had it on the 5 microvolt scale when I was looking at my lab supply, and we basically didn't see much on there at all. So I'm going to go all the way down to 5 millivolts. Whoa, we got quite a big signal there. So this is on 5 millivolts per increment, and we're 1, 2, 3, 4, about 4.5 increments. So 4.5 times 5 is about a little over 20 to 25 millivolts noise. Now let's see if we can sync that. Let's go up high. There it is. There it is. Wow, look at that signal. This is the signal. And now I'm on the 10 microsecond scale. The sweep speed is 10 microseconds. So this is pretty high frequency. It's not 60 cycle AC hum. It's high frequency. And it's pretty significant. Now, like I said, if you remember, if you go back to my previous video on the lab supply output, or if you remember, I could barely see any AC ripple. I mean, it was way down there in the mud. I am really seeing it now. So this is the culprit. This is what that radio does not like, is that switching noise, because it's a switching power supply, and it does not like this. And it even has, you can see there's spikes that are even higher. Let me come down here to, back down to 50 millivolts per scale, per unit on the scale. And I can see just barely in there some other larger spikes. See it right? I don't know if you can see it on my camera or not. Let me zoom in. I don't know if that'll help any. Move the camera a little bit. So there are, and let me turn the lights off for a second, make sure I don't turn off anything I shouldn't. So now it might show up, but you can see right here, there's huge, what appears to be spikes. And the scope is not doing such a good job of picking those up. And let's go to manual sync and see if I can get that thing to sync a little better. No. Oop. And I'm not sure what I'm seeing here, but there is some other noise there. And if I go to maximum, it doesn't show there. And maybe it's just the scope, but I've got this big fat signal, and then I've got these what look like spikes on that signal. So yeah, this, I can see why the radio doesn't like this AC adapter. So I've got one other thing I'd like to try. Let me turn it. Oh, I keep leaving that meter on. It's going to kill the batteries. Is I have, let me get it down on the floor here. Another thing I was experimenting with is one of these, if I get it out here. And I'll zoom out on the camera. Oops, that's in. Okay, one of these little converters. I did a video on this converter. It converts a DC input 0 to I think 50 volts to a DC output of something less than that. So I could take one of my 12 volt or 13.8 volt DC power supplies, it's pretty heavy regulated, put it through this and crank it down so that it only puts out 9 volts. Now, my research tells me that this also has a switching converter, which could cause this same kind of noise, and I still can't use it. Now, I did not hook this to my radio. I was a little hesitant to do that. Plus, I'd have to kind of have something temporary, a little dodgy as far as connections and everything. So I hadn't done that because I wanted to wait until I had a working oscilloscope so I could look at the output. So that's where we are there. So I may go down that path again, put it on the oscilloscope and see how it does. Because I do have 2 or 3 of these regulated power supplies that are used for amateur radio equipment or CB equipment, so that you can use portable, which usually uses 12 to 13.8 volts in your shop, and connect it to the AC power. So that's where we're at. I'm just going to see how. Whoa, boy, that load is a heavy load. Those power resistors are getting toasty. Just out of curiosity, I'm going to try to take the load off of that AC adapter and see what this waveform does. So we're going to try to, well, let's see. I got to figure out how to, this is so dodgy. I got to figure out how to disconnect the load without disconnecting the scope. And I think it's this lead right here. Oops, I lost the other connection. Ooh, that's even worse. Let me get that back on there. Wow, this is kind of bizarre. I guess I don't have it on there yet. Don't have a good connection here. Oh, I know why. I'm not in the right position. I got it there for a second and it goes away. I don't have the right tool to connect to this adapter connector. I don't know why I can't get, I should be getting to it right there. Nope, no, I'm not getting to it. It just fell off again. I was afraid if I touched the setup I had, I would lose it. And I have. You can see it every once in a while. You can see it pop up when I'm probing this. Stand by. Yeah, I was afraid if I touched anything here, I would lose it. Let me try something really radical here. I'm going to shove a screwdriver into this connector and then try to attach the screwdriver. Okay, that should be connected. Let me go back to auto sync. Okay, there it is. Back to auto sync, and this is with no load on that power supply, which is typically, that's not a good situation. Typically these switching regulators want some kind of load, because if you look at the output voltage on these things when they don't have a load, they're typically way higher than they are rated at. And they'll go up, instead of 9 volts, they'll go up to 12 volts. They need that load. So there's no load on there now. We're getting this switching pattern, It's very pronounced. I'm on the 50 millivolt scale. I'll go to the 5 and it's off scale. So we've got, and it's about 1 unit, so we've got 50 millivolts of this ripple now, high frequency. We're on the 1 millisecond scale time. Yep, that's where we're at. And so you can see that. And if I go to DC, this is AC, go to DC, now we got to go up to 5 volts. And we're only 1 unit. So that's only 5 volts. That doesn't sound right. We checked, oh, the scope has drifted. Let's reposition this back to the 0 position and then go to DC. And we're getting 9 volts, thereabouts. So this is with no load on the regulator. This is what it looks like as far as AC ripple. We'll turn the gain back up on the vertical. There's 5 millivolts per division. And 1 microsecond sweep speed. So that's it. Definitely throw this little adapter back in the box. Won't be able to use it on this radio. If you enjoyed the show, please give me a thumbs up. I got through the whole video without blowing anything up. Surprise, surprise. Bye-bye.